Okay, so again, this is video lesson 4.2 in Algebra 2, and we are factoring greatest common factor. Factoring that's a special word, and a lot of people don't understand what it means. But basically what it means is to undistribute. So, when you distribute, you're taking a couple of polynomials. A lot of times one of them is a monomial and the other one may be a binomial or a trinomial, or it could be two binomials or two trinomials. But you're going to distribute one to the other by multiplication, okay? So factoring is the opposite of that. It's undistributing, and frankly, the math operation for factoring is to divide. So that's what we're going to be doing, is dividing. So this supports video lesson J.1, okay? IXL lesson J.1, I'm sorry. But it also is applicable to all of the factoring assignments that you get with IXL. So I told you J3, J4, they all use this. All right, and so then of course, that you have to upload your notes to me. Don't forget to do the header. So this is the information on the header again. And you would upload this to me either to the Student View Dropbox or to my email by 11:59 p.m. Saturday night. Okay? All right. All right, so what we're going to do now is we're going to just do some simple factoring here. And I kind of took these from different places, so I ended up with slightly different fonts. But the first one here that you see, this looks like an ordinary distribution job. So if I were to distribute, I would be distributing the 2x to the x, which means I would be multiplying those together, right? And then I would get a result, okay? The opposite would be to turn them back into their two terms. So frankly, this is a factor of the binomial, and this over here is also a factor. These are both factors, okay? So you multiply those together normally using distribution, and when you multiply them, 2 times x is 2 times 1x is 2x, but you've got another x here. So this would be 2x squared. All right, so think about it this way, just to make sure we're clear on this. You're multiplying 2 to a 1 that's implied to be in front of the x, so 2 times 1 is 2, and then you're multiplying the x to the x. And you do that, of course, when you're multiplying together two variables, you're adding together their powers, and there are implied powers of 1 for each of these x's. So you end up with 2x squared. And then when you multiply 2x to 5, the 2 is multiplied to the 5, so that's 2 times 5 is 10. And the x here comes along for the ride because there is no like over there, so this is 10x, right? Okay, so that's just distribution for this simple problem. So this is precursor stuff. This isn't what we're actually going to be doing. This is the opposite of what we're doing, but I'm trying to show you when you break it up, when you go backwards, which is what we are going to be doing next, is we're going to be factoring, taking out factors. So what are the factors over here? Well, okay, again, this is a factor. So 3xy, we're going to multiply it to 2x plus 3y. So this is the other factor. Two factors. And so, think about it this way. Let's just say we have 3 times 5. These are each factors. You got two terms multiplied together. That's what's going on here. That's what's going on here. When you multiply them together, you get 15. So let's apply these two together. Well, again, I would multiply the numbers. So 3 times 2 is 6. x times x, whenever you multiply variables, you add together their powers. So this is x to the 1 and x to the 1. So that's x to the 1 plus 1, or x squared. And then you don't have any y's over here, so this other y just comes along for the right. And so you have 6x squared y plus, all right, and then you multiply 3 times the 3. Let me do my little distribution arrows. 3 times 3 is 9, and 3 times x, oh, I'm sorry, 3 times 3 is 9. X times, oh, there's no x's over here, so that x just comes along for the ride. And then I've got y times y. Okay, so those are that's y to the 1 and y to the 1. So that's y to the 1 plus 1, or y squared. So this basically is the same as this. These are the multiplied together terms. Okay, this is the result. This is the result, or if you will, the product. Okay, this is the result or product. That's what they call the result when you multiply two factors together. You call it the product. Okay, all right, last one over here. This one looks a little gnarly. And to be honest with you, we probably aren't going to get as complicated as this, but it's all multiplied together the same way, same principle. So again, this is a factor, which you're multiplying to this factor here. But what we're going to do is we're going to distribute, let me just use a pencil over here. So we're going to distribute all of this number to this number and to this number that's inside the factor, the second factor here. Okay, so again, factors are two terms that are multiplied together, and you'll notice that the 4a squared b is multiplied to the other factor, which is 3ab squared minus 2ab. So think of it that way. Just chunk it, break it down, and you can see the simpleness up behind all of it, even if the factors themselves look complicated. Well, let's multiply the first factor to the second factor. So we've got a number over here, it's 4, and you've got a number here, it's 3. So 4 times 3 is 12. That's easy. Now I have a squared, and I have a, which is really a to the 1. And remember, variables, you add together their exponents. So 2 plus 1 is 3. 12a, 3. Okay. And then I have a b here, and that's b to the 1. And I have b squared here, so that's b to the 1 plus 2. So that's also, well, that's b now also to the 3. Okay? All right, and then when I multiply the factor to this term over here in the second factor, I've got a subtraction or negative sign. So positive times a negative is negative, right? So 4 times negative 2 is negative 8. Okay? And then I have a squared times a to the 1. All right, and so I add together their exponents. A to the 2 plus 1 is a to the 3. And then I have b to the 1 times b to the 1. That's b to the 1 plus 1, which is b squared. And you see I've got my result. So pretty simple when you follow this. This is multiplying together again two factors, which are two terms, two separate terms multiplied together. That's what's happening in each case. Okay, and then you get a result, which is a product. Okay, and that's just the same as this simple situation that we have up here that I showed you, where you're factoring the two terms or numbers, 3 times 5. I'm sorry, you're not factoring them, you're multiplying those factors together. 3 times 5, just like you're multiplying these factors together and these factors together and these factors down here together. You get 15. That's your result, the product. All right, so now to go backwards. All right, so now we want to factor out the greatest common factor, which means when they tell you to do this, factor out, they're telling you to divide it out, okay? Or undistribute. So these are the results, right? This was what we call the result or product. Okay? It's the result or the product. That's what this is. All right, so I have 3x plus 9. Well, if I want to factor it out, I've got to divide out or the common number that I would find in each term. So if I'm looking at that, I'm going to say, okay, can I divide anything out of 3? Well, no, it's a prime number. And then the x here is all by itself, so it's got to stay. But this 9 here is 3 times 3, so I can divide out of 3. All right? Can I divide a 3 out of 3? Well, yeah, they're not, even though it's a prime number, you can always divide it by its factors, and factors of 3 are 1 and 3, and factors of 9 are 3 and 3. So literally, I'm going to do this. I'm just going to divide by 3. Why? Because undistributing is dividing out. So I can divide out a 3 on each of these, and so I'm left with, well, 3 divided by 3 is 1, so I'm left with 1x. Okay? And what's 9 divided by 3? Well, that's just 3. X plus 3. Pretty simple. So now, x plus 3 is what I divided out, but this 3 doesn't go away. It's actually over here. This is really 3, if you will, times x plus 3. So the two factors that you're left with are 3 and x plus 3. Okay? So if they want you to factor it out, this is what you come up with. You never get rid of the 3. It just is, now it's just multiplied to the x plus 3. So this is your answer here that I've got in the box. Okay? All right. So we're going to do the same thing over here. Divide out. So let's look at 15. 15 we know has factors. Let's just think the common ones are 3 times 5, and then this is a 5. So 5 and 1 and 5 and 3 here are factors, and 5 and 1 are factors here. So we can divide out a 5. And then x squared, we've got an x squared here and we have an x. Now, can we divide out something out of these? Well, yeah, we can divide an x out of both of them. So when I do that, that means I'm going to divide out, in this case, we said 5 is common, right, to both terms, and x is common to both terms. So lowest common denominator, if you will. And I'm going to divide the same thing out of here, 5x. Now when I do that, what's 5 divided by 15? It's 3, right? And so this leaves a 3, and this is just 1. And then x squared divided by x, well, that's really x to the 2 minus 1. When you're dividing a fraction of exponents, all you're doing is subtracting the exponents. So this is 2 minus 1, and this goes away, and so you end up with 3x. Okay, and then what is 5x? Negative 5x divided by 5x? Well, these are all the same, so it's got to be negative 1. Now, remember, we still have the 5x down here. It's multiplied to the 3x minus 1. So these are the factors. And we'll just do it this way. All right? So this is what they want you to come up with. All right? They may, in iExcel, it may just tell you to list the two factors in which you would say 5x, okay, and 3x minus 1, just separately with a comma in between them. Or it may ask you to just set it up just like this, which is what I would prefer. So I think it's this, as I recollect. And so, if you do it this way and you get it wrong, try it the other way. But this is the correct algebraic way of doing these things. All right, let's do the next one. So this one, ooh, these last two look really ugly. I'm going to tell you that iExcel basically keeps the factoring assignment at the level of A and B. But let's do this because they can be done. So let's look at the 5 and the negative 13. Well, Wow, both of these are prime numbers. So there's nothing common that I could divide out but 1, and if you do that, one always kind of is invisible to everything. So there's nothing we can divide out of there, so we have to leave those alone. But I can divide, let's see, I've got an a to the 6 and a to the 4 here. So since I've got a to the 6 and a to the 4, I can at least divide out a to the 4, because I can subtract the exponent of 4 from the exponent of 6 and get an exponent of 2. So I'm going to divide out a to the 4 on both of these. Okay? And then b to the 2 and b to the 8. Well, I can divide out a b to the 2. Okay? So a to the now to simplify this, I am going to cancel. I'm going to get rid of the a to the 4, and this is a to the 6 minus 4. So let me just write it down. So the 5 comes down here. A to the 6 minus a to the 4 is a to the 2. Now, all I'm doing is subtracting exponents from each other, right? B to the 2 minus b to the 2, well, 2 minus 2 is 0, and any number to the 0 power is 1. So these are obviously b to the 2, it's the same number divided by itself, it's 1, okay? And then over here, we've got a negative sign. If it's 1, by the way, over here, b to the 2 divided by b to the 2 being 1, I don't need to include it here. It's implied that I could multiply 1 to this, and you still have this result, 5a squared. So I bring over my negative or subtraction sign. Again, I have to bring down the 13. A to the 4 divided by a to the 4, again, it cancels out, just like the b to the 2 and b to the 2 did. And so that's 1. So now b to the 8 now minus b to the 2 is b. 8 minus 2 is 6. So that's what I factored out, and the factored number was a to the 4, b to the 2. Okay? All right, so like I said, there are several ways they could have you do this. They might ask you just to come out with a term that you, this term here, or they might have you come out with both of them. Just play with IXL on that. But these are the two factors. And this one. And that's what they want. Okay, last one. Okay, I got 4, I got a 12, I got a negative 2. I can divide out 2 out of all of these. So again, you always go to your lowest common factor, okay? Or 2. So I'm going to divide out a 2 out of each one of these. And then I have x squared, x, and an x cubed, so I can divide out at least an x out of all of these. Okay. And then I've got a y here, a y squared here, and a y cubed here, so I can divide out a y out of all of these. So notice I get the lowest value for each term, or lowest value for each number or letter, number or variable. Okay. All right, so 4 divided by 2 is 2. X squared over divided by x is x to the 1. Y divided by y is 1, so I just leave that like it is. And remember, I have 2xy is what I am dividing out of all these things. And then 12 divided by 2 is 6. X divided by x is 1, so I'll just leave that out. Y squared divided by y to the 1 is y. All right, and then let's see. 2 divided by 2 is 1. I've got the subtraction sign in front of it. X cubed divided by x is x to the 2. And y cubed divided by y is y squared. So that's the rest of it. These are the two factors. So this is the factored result. Okay. All right, so that's it. So that took us about 20 minutes to do. And I'm going to go ahead and stop the recording here. And you can proceed on to the other materials. I'll talk to you about that in just a moment. Let me